Hello everyone. In this session of CCNA series, I'll discuss about two commonly used network cable types, copper and fiber. Network cables are used to connect devices and transfer data or information between those devices on an Ethernet network. These cables are essentially the carrier or media through which data flows. There are two types of cable we can use for Ethernet networks: UTP, unshielded twisted pair, or copper cable. The second one is the fiber cable. Unshielded twisted pair cable use copper to transmit an electrical signal. To create the electrical circuit, we use two wires inside the UTP cable to create a loop which allows electricity to flow. To send data between two devices, it uses encoding scheme. When we want to send a 1, we send a high voltage, and when we want to send a 0, we send a low voltage. When both devices use the same encoding scheme, we can exchange the data. One issue with the electricity when sending it through a wire is that we get EMI, also known as electromagnetic interference. Twisting the cables helps to cancel most of the EMI between the wire pairs. Let's understand the physical components of UTP link. The term Ethernet link refers to any physical cable between two Ethernet nodes. The cable holds some copper wires grouped as twisted pairs. Many Ethernet UTP cable use an RJ45 connector on both ends. To complete the physical link, each node needs an RJ45 Ethernet port that matches the RJ45 connector on the cable so that the connectors on the end of the cable can connect to each node. The cable with connectors is then connected to a NIC network interface card or a switch port. PCs often include this RJ45 Ethernet port as part of a network interface card. Switches typically have many RJ45 ports because switches give user devices a place to connect to the Ethernet LAN. UTP cables can be wired as straight through or crossover. Straight through cables are primarily used for connecting unlike devices, such as switch to router, switch to PC or server, hub to PC or server. And crossover cables are used for connecting alike devices, such as switch to switch, switch to hub to hub, router to router, router Ethernet port to PC, NIC, PC to PC. Three most commonly used Ethernet standards for coppers are 10 base T or Ethernet, 100 base T, also known as fast Ethernet or FE, and 1000 base T, also known as gigabit Ethernet or GE. You can identify an IEEE standard name if it is the copper when it includes the letter T. The advantage of UTP is that it's very cheap and it's easy to work with. The capability of many UTP-based Ethernet standard to use a cable length up to 100 meters means that the majority of Ethernet cabling in an enterprise uses UTP cables. One of the disadvantages is that you can only use it up to 100 meters. This is where our next topic comes into picture. Fiber optic cables. Fiber cables Fiber optic cables are a high-speed data transmission medium. It contains tiny glass or plastic filaments as the medium through which light passes, varying that light over the time to encode zeros and ones. Digital data is transmitted to the cable via rapid pulses of light. The receiving end of a fiber optic transmission translates the light pulses into binary values, which can be read by a network device. Let's see what are the components of fiber optic cable. Fiber optic is actually composed of two layers of glass, starting with the core, which carries the actual light signal, the cladding a layer of glass surrounding the core. Cladding and core work together to create the environment to allow transmission of light over the cable. The three outer layers, buffer or coating, strengthener, and cable jacket, These layers of the cable protect the interior of the cable and make the cables easier to install and manage. When using fiber cable to transmit between two devices, you need two cables for transmission and for receiving, one for each direction as shown in the figure. There are two main types of fiber optic cables: single mode fiber or multi-mode fiber. The difference is basically in the size of the core. SMF has very narrow core, typically around 9 micrometer, which allows only a single mode of light to propagate. Single mode allows distances into tens of kilometers, but with slightly more expensive SFP or SFP plus hardware. MMF multimode fiber has much wider core, typically around 62.5 micrometer or 50 micrometer, allowing multiple mode or rays of light to propagate. Fiber allows for distances of up to 400 meters. Some of the commonly used Ethernet standards for fiber are 1000 base LX single mode, 10G base S multimode, 10G base LX4 multimode, 10G base LR single mode, 10G base E or ZR single mode. That's it for this session. I hope this was helpful for you. In my next session, I'll discuss about Ethernet shared media and point-to-point connections.